Well, hello everybody. It's Scott Roberts here at Explore Scientific, and I thought it would be a good idea to give you some coming attractions of this week. Of course, today is the anniversary of Yuri Gagarin's historic flight, where he was the first man to orbit in space, and so there's lots of various celebrations going on. There's Yuri's Day and several other celebrations that are happening all over the world for Yuri Gagarin. If you check out his Wikipedia page, I think you'll find lots of very interesting information. But to say the least, having a man in space orbiting the planet really kicked off the space race or put it in high gear. I would say that Russia launching the world's first satellite started it all. That was the real spark. But now we had human in space as well. So, and since that time, we have gradually become this spacefaring species, which I would claim today. So anyways, incredible story about Yuri, and tragically he died fairly young, so was never able to travel in space again. Today is also the anniversary of the Space Shuttle Columbia. It was the first launch in 1981. And also today, not an anniversary, but it will be our 5th anniversary of How Do You Know with Dr. Daniel Barth. So he's going to cover a presentation called From the Apple to the Moon, largely discussing Isaac Newton's principles of gravity. On the 13th, which is kind of cool, the moon is going to pass 2 degrees south of the planet Uranus at 8 o'clock in the morning Eastern time. So this will be a real challenge to see if you got a good horizon view, and also to check out, to see if you can capture Uranus, maybe with the naked eye, or a pair of binoculars would be good. So. But it will already be daylight, so you're going to want to be very, very careful, in trying to do this. And then I'm taking off the 13th. Normally we would have Global Star Party, but I got my second Moderna vaccine, and I am just kind of take it easy. I may be kind of out of it. I was out of it on my first vaccine for about a day afterwards. So we'll see. I mean, maybe it's nothing, but if so, I'll pop back in. Otherwise, I am going to take it easy. On the 14th, we're going to celebrate Christian Huygens' birthday. And he was born in 1629. He is just an amazing person overall, involved in chemistry and involved in optics. And he polished up some of the very first very successful eyepiece designs, which is called the Huygens eyepiece design, and it eliminated a lot of distortions and stuff. So being an eyepiece manufacturer, I like to tip my hat to Christian Huygens. He's a great guy. Then we have, let's see, on the 14th, Kent Martz will be back on with First Light Chronicles. He's going to still cover more of the Astronomical League's Universe Sampler program, which we've been covering. That'll happen at 4 o'clock. And then there is, I think on the 14th also is the start of the Lyrid meteor shower, which is going to peak on or around the 22nd of April. So you're going to want to check that out. You might see some early stragglers coming in, and so that'll be really cool. the 15th, Jerry Hubble will join us for the Open GoTo Community Live. He would have, I think he's already going to have launched the new firmware that we talked about on our last show. And then on Friday, April 16th, we're going to have the 41st Global Star Party, which will be a lot of fun. And we will also at 4 p.m. on Friday do the second episode of MicroCosmos Voyages, which takes you into the microscopic unseen world. And we're going to show you how to prep up a cover slip on a microscope slide and share some live specimens with you that I have coming this way from courtesy of Carolina Biological. So there's also on the 17th, the red planet Mars is supposed to be 0.1 degrees away from north of the moon. There's some other things that are happening. Comet Atlas is brightening. It might get to like magnitude 4.8, or excuse me, 8.4, not 4.8, 8.4, something in that range, maybe 8.5. These comets are unpredictable. But I do give you a link in this coming attractions page on the comet page of Saiichi Yoshida, who has probably some of the best information for observations of comets. And then I found a couple of new visualizations. One of them is from NASA, from the Lunar Reconnaissance Orbiter, the moon's south pole, where they show sites of perhaps where we build the next or the first colony on the moon, because this will be an area where we can find water and we can find areas of sunlight and constant sunlight if we need it for solar power, these kinds of things. So certainly something to check out in this program. And then we have a beautiful program from NASA's NICER mission where they found X-ray bursts in the Crab Nebula's Pulsar. So this is these are two visualizations coming up right now. So hope you guys join us at 4 o'clock for Daniel Barth. And until then, I will see you later.
NASA's NICER X-ray telescope on the International Space Station.
Let's do this one first.
Is a fascinating region to study, especially when you pay attention to the areas that are in sunlight and darkness over time. And thanks to NASA's Lunar Reconnaissance Orbiter, we can zoom in for an extremely close view of the terrain that shows how the sun shines on the South Pole. Here, we see how the moon's topography creates areas of shadows over the course of 2 lunar days, which is equal to 2 months on Earth. The flowing dance of sunlight and shadow on the surface reveals areas that exist in permanent darkness, nearly persistent sunshine, and others where the balance of light and dark fluctuates through time. Studying the shadows at the South Pole informs scientists about the temperature at and below the surface, and the possibilities regarding water and other volatiles, all of which sheds light on what future lunar exploration will entail.
NASA's NICER X-ray telescope on the International Space Station has just shown that random outbursts from pulsars pack more of a punch than previously thought. Pulsars are rapidly spinning neutron stars, the crushed cores of exploded stars. One of the best known pulsars lies at the heart of the famous Crab Nebula, located about 6,500 light-years away. Light from the supernova that formed it reached Earth less than 1,000 years ago, in the year 1054. The Crab pulsar spins 30 times a second and steadily blinks in radio, visible light, X-rays, and gamma rays. But it also emits random jumbo bursts called giant radio pulses that can be more than 10 times stronger than its regular signals. Now, thanks to NICER's sensitivity, astronomers have shown that each giant pulse comes with an increase in X-ray brightness as well. Observing the crab simultaneously with NICER and radio telescopes in Japan, astronomers captured data over some 3.7 million rotations. They show a nearly 4% increase in X-ray emission with each giant pulse. This means the phenomena responsible for giant radio pulses produce 10 or more times the energy previously estimated from radio and visible data alone. Astronomers think all these signals originate from particle interactions in the pulsar's rapidly spinning magnetic field, but the details remain poorly known. Better understanding of giant pulses may help scientists figure out how pulsars like the crab do what they do. It may also provide us with insight into a much more powerful phenomenon called fast radio bursts, which are linked to spinning neutron stars in our galaxy and others much farther away.